The machinist has 6 units of metal and 28 hours of free time, in which he will make 2 models of decorative computer screens. He estimates that model 1 requires 2 units of metal and 7 hours of time, while model 2 requires 1 unit of metal and 8 hours of time. The prices of the models are $120 and $80 respectively. So model 1, $180, model 2, $80. Use the graphical method to determine the number of decorative computer screens of each model the machinist should assemble if he wishes to maximize his sales revenue. So colleagues, this topic is on linear programming. Linear programming helps us determine, because remember, every business, you don't have all the resources you have. You don't have all the resources you can get. You are limited with your resources. So with this limit of resources, you want to find what's the best combination of goods that I can produce with my resources. Okay? Our resources here are 6 units of metal. We've only got 6 units of metal, and we've got 28 hours of time. So how are we going to efficiently utilize these 6 units and these 28 hours of time so that we maximize our sales revenue? That's what we're asking, okay? How do we maximize our sales revenue with our constraints of 6 units of metal and 28 hours of free time? Okay, so basically, all in all, we're just trying to decide how many units of model 1 and model 2 do we need to make with these constraints. So the first thing is you're going to label your variables. Okay, you're going to say, okay, let X be the number of model 1 screens and let Y be the number of model 2 screens. Okay, that's the first thing that you do with linear programming, because you're going to be dealing with a graph, so you need to know what's your X variable, what's your Y variable. That is step 1. X number of model 1 screens, Y the number of model 2 screens. Then the next step is you need to make your constraints. Okay? You need to make your constraints. The constraints on what? Metal and time. Okay, because as we said, metal we've only got 6 units. Time we've only got 28 hours. So these constraints are basically an equation that you have to form. Alright? So in the equation, they told us we have 2 units of model 1. That's why I've put 2x. X is a number of model 1 screens. And I've told us 2 units of model 1 screens, so I'll put 2x here. Okay. Y is the number of model 2 screens, and they told us 1 unit of model 2. Okay, this is in the equation here. Okay, model 1 requires 2 units of metal. Model 2 requires 1 unit of metal. Okay, so your metal constraint, remember, you've only got 6 units of metal. That's why I put this sign, less than or equal to 6. You can't go above 6. You've only got 6 units of metal. Model 1 needs 2 units. Model Y needs 1 unit. Any question before I go further? Right. Then time. Time is our second constraint. Alright. In the question they told us for model 1 it requires 7 hours. That's why I put 7x here, okay? 7 hours, model 1 units. And then model 2 8 hours. That's why I put 8y here. And our the maximum time we have is 28 hours. So this is our second constraint. Any questions before I move further? This non-negativity is just telling us you cannot get any negative values of x or negative values of y. Basically, you cannot make negative 2 units of model 1, or you can't make negative 5 units of model y. Okay, so always in these linear programming questions, add this. Okay, it's 0.5 max, but 0.5 can take you a long way. Then we have to formulate our revenue function, because we want to maximize our revenue, right? And we were told the prices, model 1 is $120. That's why I've put 120x. The price of model 2 is $80. That's why I put 80y. So now we are going to use the graphical method so as to determine how many units of model 1 and model 2 we can make with our constraint time and number of metal units. Okay. So this is how you make these graphs. Maybe let me just make a new page here. Show you how the graph was formulated. Okay, so for each of these lines we have to put it on our graph. So remember, a graph, you first put your x and y axis. So you put the set here. So we'll start with our first line here. Okay, so you're going to say 2x plus y equals 6. Right? This is one way you can easily make these lines here. You're just going to use intercepts. Okay? I'll show you what I mean. Alright? So you just say, okay, when x equals 0, substitute it into this function. 2 times 0 plus y equals 6. 2 times 0 is 0. So when x equals 0, y equals 6. Okay, so when we don't use any metal for model 1, we can use all the 6 units of metal for model 2. So this y equals 6, we're going to put, this is going to be our first point here. Okay, 0, when x is 0, y equals 6. So that is our first point here on the graph. Any questions before I move further? Okay, then you do when y equals 0. Okay, basically, if we are not making any units of model 2, how many units of model x can we make with? How many units can we make? So 2x plus 0 equals 6. Okay. equals 6. Divide both sides by 2. X equals 3. Okay. So our second point here on our x-axis, when y is 0, x equals 3. So you just connect this line. This is the first line for the metal constraint. Okay, this is our line for the metal constraint. Any questions before now I go to the line for the time constraint? Okay, so we deal with this equation here. 7x plus y plus 8y equals 28. 7x plus 8y equals 28. Okay, so you're going to say again, when x equals 0, so we're spending no time on model 1. Yeah, so you substitute x for 0 there, so you're going to say 7 times 0 plus 8y equals 28. So 1 times 0, that is 0. So you say 8y equals 28. Divided by 8, 3.5. I'm not mistaken. 8 divided by 8. Yes, 3.5. So when x equals 0, y equals 3.5. So since we're not using a graph paper, if you're using a graph paper, it's easy to do this, but I'm not using a graph paper here. So we'll say, okay, our point will be here. When x equals 0, y equals 3.5. Okay. Then, with this same equation, we're going to say, okay, when y equals 0, what is our x value? 7x plus 8 times 0 equals 28. 8 times 0, that is 0, so we just have 7x equals 28. So our value of x, 28 divided by 7 is 4. So we get our new point here and say, when y equals 0, x equals 4. So we draw the line. So, before I go any further, any questions, colleagues?
No, I think I'm a little bit behind on. I think this is just the issue of IT. I've been trying to draw the graph. I think I failed. How did we start drawing it? So, am I able to demonstrate? Help me demonstrate.
I'm using just when you go on thing, you just go on
Mm-hmm.
shapes, then you just click on these lines here. Okay. I like to
That's
use the draw. Yes,
under
just.
insert,
Mm-hmm.
then shade.
You just you put those lines like that. Just add all those lines and then I'm just using the draw tool, which you can also use. The drawing tool is also easy. Okay.
Mm-hmm.
Yes. To avoid a bend line for the drawing tool, first draw a bend line, then you wait for it to get straight. Then now you can draw a straight line. Okay. Even you can use that's the other method. Okay. So here on this graph, we are going to look for the feasible region. Okay, the feasible region is what you can make with your constraints. So the feasible region is the region below where both lines intersect. Okay, so let me shade the feasible region here. Just look for where the lines intersect, and then that region below. Yes, this is the feasible region. Oh, I forgot to mention one thing. Before you find the feasible region, you have to find here where these two lines intersect. What are the coordinates here? Okay. What are the coordinates there? Now, with the graphical method, because you're going to have those grids and everything, you'll be able to just see, okay, what's my y value, what's my x value. Okay. But here in this case, I haven't got a graph to do that, so I'm just going to use simultaneous equations to find this point here. Okay, where these lines intersect. We're going to use simultaneous equations because we want to find this intersection point. So using simultaneous equations, okay, using simultaneous equations, you just use those same equations. Okay, 2x plus y equals 6 for the metal constraint, 7x plus 8y equals 28 equals 2. Okay, you can use elimination method, you can use substitution method. All right, here I'll use substitution method. Why? Because I've seen there is a y variable by itself, so I can easily get the make y the subject of the formula. Okay. If you see a letter by itself, it's best to use the substitution method, okay, to be easier for you. Okay. So using substitution method, I'm going to make y the subject of the formula for this equation here. Okay. So when we make y the subject of the formula, it becomes y equals 6 minus 2x. Okay. Y equals 6 minus 2x. Okay. So we're going to say substitute this into equation 2. Okay, we're substituting into this equation here. Okay, that's what we're substituting. Where there's a y, we'll substitute it with 6 minus 2x. As you can see here, 7x plus 8 open bracket 6 minus 2x. This was where the y was. We substituted it. Equals 28. Equals 28. So you multiply 8 times 6, that is 48. 8 times negative 2, That's negative 16x. Would you kindly mute your mic? Kindly mute your mic. Yes. Then you group like terms together. Okay. This 48, it crosses over the equal sign. Okay.
Sorry, maybe I'm a little bit behind. We have found the coordinates that we were looking for.
No, we haven't found the
And
coordinates.
no. I mean the value of y and x, and we plotted the first. We've plotted the graph. Yes. Then our next step is using substitution method.
Yes.
And we have gotten the first equation, which is 2x plus y equal to 6, and we are trying to make y a subject of the formula, not so.
Yes.
Then, using the points that we had found, we are trying to substitute now, not so.
Not using the points that we found, but you are correct in that pattern. After we make y the subject of the formula, then we substitute it into one of the equations.
So it was y equal to 6 minus 2x. Is it? Then y, in this case, what was y? What did we replace with y?
We substituted this equation into this equation in red here. So where there's y, we substituted it with 6 minus 2x. Is that you had a question after that, or you are?
No, I'm okay. Thank you.
Yes. So as I said, you expand these brackets. 8 times 6, 48. 8 times negative 2x, negative 16x. And you just group like terms together. So this 48 crosses over the equal sign here, and it becomes negative. Okay. So it will be 28 minus 48. Then you're going to say 7x minus 16x, negative 9x. 28 minus 48, negative 20. To get the value of x, divide both of these negative numbers. So negative 20 divided by negative 9, you get x equals 2.22. So we found the first coordinate of the intersection x equals 2.22. Okay. Now since we're dealing with number of units, so you can, after you find y, you can now just round off. Okay? I wouldn't advise rounding off here yet. Yes. So since we found the value of x, and remember, we already formed an equation for y, which is y equals 6 minus 2x. Okay, we can substitute x equals 2.22 into this equation. Okay, and this was equation 1, which was rearranged in terms of y. Okay, or if you want, you can still substitute it in the original form of equation 1. Okay, substituting it back here. Okay, you'll still get the same answer. Where here this x is, you put 2.22 and find the value of y. you will still get the same answer. Okay. So y equals 6 minus 2x. Substitute x with 2.22. 2 times 2.22, you get 4.44. 6 minus 4.44, you get 1.56. Okay. So this intersection here, as you can see here, where these two intersect, x is 2.22 and y is 1.56. Any questions before we go to the next part? Okay. So this feasible region, FR, feasible region, you are going to test all the points on the corners of this region, okay? We'll call this point 1. We're going to call this point 2. We're going to call this point 3. And we're going to call this point 4, okay? All the corners of the feasible region, you're going to test them into this function here, which the one for the revenue maximization. This one, R equals 120x plus 80y. Okay. So all the corners of the feasible region, you are going to place them into this function to see which one will give you the highest revenue. Okay, which point will give you the highest revenue? Okay. Now in an exam, you're not going to have time to test point 1, then you test point 2, then you test point 3, then you test point 4. Okay, just test. Just use where the lines have intersected here. This 2.22 and 1.56. Just use this one. Okay. Majority of the times, it's the one that will give you the highest revenue. Where there's the intersection. Okay. So if you use this point 2.22 and 1.56, you put it in our equation here, 120, where there's x, replace it with 2.22, plus 80y, which is 1.56, so 120 multiplied by 2.22, you get 266.4. Plus 80 times 1.56, you get 124.8. So 124.8 plus 266.4, you get $391. $391.2. Okay. So for the firm to maximize revenue, it must produce, now since it's in units, so there are no decimal places, so it needs to produce 2 units of x and 1.56, we can round it off to also 2 units of y. Okay, in order to maximize revenue, you need to produce 2 units of x and 2 units of y, then they'll maximize revenue. Okay. questions? So anyway,
I'm a bit behind because maybe just to increase the just to increase the font a bit. Okay. Where did we get the x is equal to 2 and y is equal to 2? Because the equation seems different.
I'm using these values here, 2.22 and 1.56. I rounded them off because units you can't say produce 2.2 units.
Oh, I see. Thank you.
So, yeah, as I said, naturally you have to test all these points. This 0 and 3.5 here, 0, 0 and 3, 0. Okay? But you'll find that all of them, the revenue will be less than this intersection point. Okay? Yes. Or maybe let me just illustrate for you so that we get the we grasp the full concept. Okay? If we test point 2 here, where x is 0 and y is 3.5, we bring that into this equation. 120 and x is 0 plus 80 y is 3.5. 120 times 0, that is 0. 80 times 3.5, you get $280. This point here, 0, 0. The basic thing, if you don't produce any units of x or y, your revenue will be 0. Okay? So you don't even waste time trying this 0, 0 point. Then you have got this point here, which is 3, 0. Okay? 3, 0. We put it in our equation here. Excuse me. R equals 120. X is 3. So where there's x, we put 3. Plus 8y. Y is 0. So 8 times 0, that is 0. 3 times 120, that is $360.
Sorry, maybe let me take you back a bit. On the coordinates of where x is equal to 0, y is equal to 3.5. The final answer we got was still x is equal to 2 and y is equal to 2. And the one we've studied is the third coordinate where x is equal to y is equal to 0 and x is 3, is it? No. Actually, it's y is equal to 0 and x is equal to 0.
This one here, this point here.
Yes,
0, 0.
That's the third one, not one.
That's the third point, yes.
So the final comment on y is equal to 0, x is equal to 0 and y is equal to 3.5. We still found x is equal to 2 and y is equal to 2.
No. No, I'm just here. What I'm just illustrating is that these other points will give you less revenue than this intersection point.
Okay.
Yes. That's what I'm just trying to illustrate.
Okay.
As we can see, yes, the intersection point gives us $360 $191. These other points give us 280 and 360 and 0. So usually the intersection point is the one which will give you the maximum revenue.